Algebra 1, Lesson 15, and we're going to look at 16 as well. So 15 is all about using the distributive property, and we can start out by looking at the distributive property to say that we have a single term outside of the parentheses, and we need to multiply it by everything inside the parentheses. So looking at these variables, we have a times b, sorry about that, a times b, let me get rid of what we have here, a times b, and then we're going to do a times c. We can show this visually with little rainbows so that everything outside of the parentheses is multiplied by what is inside. And we can do that with this example with numbers below. 6 times 2 and 6 times 4x. Well, 6 times 2 is 12. 6 times 4x is 24x. And the question is, what do we put in between these? Do we multiply them? Do we add them? Well, we put whatever we have within the parentheses. So we add them. And it's a very, very common mistake for students to say, this is 36x, or this is 36, or whatever it might be. Unfortunately, that is incorrect, because 12 is a different term than 24x. These are not like terms, because 24 has an x multiplied to it, and 12 does not. We cannot compare these. We cannot add x's where there are no x's, which means we can't combine these. Looking at these ones here, let's just do a couple of them and then see if we're correct. So 7 times y is 7y, and 7 times 3 is 21. And if we bring it through our tunnel, we see that we are correct. 7y plus 21. Let's try another one. How about 5 times 4x is 20x. 5 times negative 5 is negative 25. We keep that subtraction sign, or we can think of it as a negative 5 that we have to multiply by. So we get 20x minus 25. All right, last one here. We are multiplying negative 9 by everything inside the parentheses. So we get negative 36 and minus 18n. Here we go. And when we look back, we see we get negative 36 minus 18n. Both of those are negative because that outside term needs to be multiplied, and it brings that negative. We can come to things like this that end up being a little bit more complicated, and one way that you can help yourself is by multiplying out and writing out exactly what you are multiplying. And the thing is, we multiply this outside term, AB, by every term inside. If you remember what terms are separated by addition or subtraction signs. So we need to do AB times AX. We'll simplify in a second. We will do plus, because we're going to bring down that addition sign, AB times a negative 3x, and then we will have plus AB times AB. Okay, well, let's simplify. If we look at this first term here, the only things that we can kind of bring together and simplify are the a's. And we get a squared bx. And if you had a squared xb, that's the same thing, okay, because multiplication is commutative. Next one, there's no variables in common, so we just say we have negative 3, always putting that number out front, a, b, x. And then we have AB times AB, which brings us to a squared b squared. It would not be correct to say AB squared, because that's only telling me that the b is squared, but we also have the a squared. So we say it's a squared b squared. So show all of your rainbows, and I'm missing one here, there we go, and then multiply together, simplify. Let's try another one. All right, let's look at these. So if we see a negative sign on the outside, that's technically a negative 1. We're multiplying by everything inside. So we get negative 9 minus 4. or you could say plus a negative 4. It's the same thing, but we get a negative 13 either way. Here, negative 9 times negative 6 is positive 54. And then we could technically say minus a negative 27, or we know that's plus 27 when we do our second rainbow. Well, when we add those together, we get 81. It doesn't really matter if the 6 is on the front or the back. Normally we see it in front of the parentheses, but it distributes just the same to get 30 minus 6x. And this mn multiplies the mx to get m squared nx. Okay, we do it again, and we see we have two n's, so we have plus mn squared y, and then a third one to say 2mnp. Okay, start out using those rainbows, which will help you to visualize what's going on. All right, let's just try a couple more. Okay, if we distribute this, let me erase that. If we distribute this, we see we're going to have quite a few x's and y's. So we get 4, and now we have x to the 5th, y to the 4th. Distribute again, we get negative 20, being able to multiply the 4 and the 5. We have 2 x's multiplied together now, and we still have that y to the 3rd on the outside. These are not like terms. We don't have the same variables with the same exponents, so we can't do anything at this point. That's it. Okay, when we look at the next one, we're going to have a lot of m's, right? We have negative 2x squared. Nothing's going to change that, but now we have 4 m's multiplied together. And lastly, a negative 2 times a negative 4 is a positive 8. We still have 2 x's multiplied together, but now we have 3 m's. Those are not like terms, so we leave them as is. Lastly, let's look at a word problem that we can use the distributive property to solve, like this. Turf on a football field is being replaced. The field is 300 feet long and 160 feet wide. But we know that we have end zones on the field as well, which mean that they are going to add 30 feet to each side. So use the distributive property to show the area of the entire field. Well, from what we know of area, I need my length times my width. Well, let's start with our width, and our width is 160. My length that I'm going to multiply by, well, we have it in different chunks, so I'm going to write out all of those chunks. And to get the entire length, I am going to add up 300 plus 30 plus 30. This shows the distributive property because we could take 160 and multiply it out to each of these, add them together, and get my answer. So one way to show the distributive property. Let's go on to lesson 16. In lesson 16, we are looking at variable expressions and how to simplify them. Basically, being able to take a formula and plug in numbers. Now, there are two ways to go about this. One, we could start out by distributing all of these variables and then plugging in the numbers that we know. So let's do that first. And I'm going to start within my parentheses and say negative a times p and then negative a times negative a. And I'll get my negative a still on the outside times negative a p plus a squared. And then we are going to have to distribute this negative a. And I will get a positive a squared p plus a negative or minus a negative a to the 3rd. And now I can use this information over here to plug in numbers. So I will say a is 3, so we have 3 squared times 4, because p is 4, plus a negative 3 to the 3rd. Okay? Well, we can simplify out and say 3 squared is 9 times 4. Well, that's 36 plus 3 to the third is 27, but we have it negative, so we have a negative 27. So my final answer, 36 plus a negative 27, is 9. So that's our first way, distributing out our variables so we can have one simplified expression, and then we plug in our numbers. The second way to do this is plugging in the numbers first and simplifying using order of operations. So we could say, plugging in our numbers, we have negative 3 times the quantity, negative 3 times those parentheses 4 minus 3. Just plugging in where I see A and P. Well, we start with our parentheses inside of those brackets, so 4 minus 3 is 1. We're going to multiply that by negative 3 and then by negative 3 again. Well, negative 3 times 1 is negative 3. And then I'm going to multiply it by negative 3. Well, that just gives me a positive 9. And we can see that both ways give me the same answer, which is what we want. So let's try this second one again with our two methods. Okay, one is simplifying with the variables, and we have to distribute this negative sign first. So we get negative x plus a minus x plus a, because that negative is being distributed. So we can simplify our x's together and get negative 2x. We can simplify the a's together and get 2a. So that when we plug in our numbers, I will say negative 2 times 7 plus 2 times negative 2. And I will get negative 14 plus a negative 4, which gives me negative 18. Let's see if my other way, my second way of just plugging in the numbers, will also give me negative 18. So I'll plug them in and say I have a negative x, so a negative 7, plus a negative 2, minus a, let's see, 7 minus negative 2. Okay, well, negative 7 plus negative 2 is negative 9, minus, inside of here, we're going to get 7 minus negative 2. That becomes a positive, so we have minus 9. Well, negative 9 minus 9 gives me negative 18. So it works. You have two methods of going about this. In some ways, this simplifying the variables will be easier, and in other ways, just plugging in the numbers will be easier. These skills are extremely helpful for our formulas. So let's just do a couple of these. Let's try this bottom one with the x's, a's, and p's. And I'll do it up here. So we have negative 3, just plugging in the numbers. Okay, this is, or I'll show method number 1 first, since that's how I did it on the other page. So method number 1, we would simplify the variables. And if we look at this, we can see that if we have x times 4ap over xp, well, the x's are actually going to cross out, right? X divided by x is just 1, and the p's are going to cross out as well, which means we just have 4 times 1, or 4. Super easy that way. Compared to if we were to do method number 2, and we say negative 3 times 4 times 1 times 5 divided by negative 3 times 5. Well, we simplify and we get 20 times negative 3 on the top, which is negative 60, divided by a negative 15, which gives us 4. We get the same answer, but definitely a little bit more challenging. Okay, so use that distributive property or simplifying when it is in your best interest. See which one might make more sense. Okay, these are all extra examples that you can use to practice for yourself with this concept. All right, all it is plugging in numbers or simplifying first and then plugging in, whichever one you desire. This one was where it gets a little bit more complicated, but still we are just plugging in numbers. So we have a savings account that increases its interest according to the formula P sub y equals 1.04 times P sub y minus 1. where P sub y is the principal balance at the end of y years. Okay, so maybe at the end of 10 years, 5 years, and P sub y minus 1 is the principal balance after y minus 1 years. Meaning if we're looking for year 10, P minus 1 is the balance for year number 9, the year before. After 6 years, there's a principal balance of 1450. How much do we have after 8 years? So we're given this, that for year 6, we have 1450, but we want year 8. Unfortunately, to be able to get year 8, I'm going to need to know year 7. So let's find that. The principal balance of year 7 is 1.04 times P sub 7 minus 1. Well, P sub 7 minus 1, that's just P sub 6, and I know that. That's what's right there. So I can just say that P sub 7 is 1.04 times 1450, because that's our principal balance for year 6. And if we multiply that out, 1450 times 1.04, we get 1,508. So we have found P sub 7, 1,508. Now we can actually do P sub 8, because that's going to be 1.04 times P sub 8 minus 1. And thankfully we know that information because that's just P sub 7. So we plug it in. P sub 8 is 1.04 times this 1508 that we got for year 7. And we multiply it out. 1.04 times 1508. And we get 1,568.32. So by year 8, we will have gained quite a bit of interest, and we are now at $1,568.32. Okay, so there's a couple steps to this, but not too bad once you see what they are asking you to do is just plugging in some numbers. I hope this is helpful for your homework and for studying.